So we'll go. Okay, we're gonna get some C++ done, right. Okay. Right. Okay, I feel like right. I have to go back a little. And okay. Nope. Still okay. String vectors and array. I'm not there yet. So right. And there I am. Okay. Now I feel like I have to do these exercises. Right. Okay. So let's get to this exercises. Defining header file. Okay, exercise 3.6.2 1.22. Okay, let me see what is 1.2.2 what 1.5.1 1.5.2 and 1.6. Okay, let's see. Yeah, okay, so this should be around 1.5.1 1.5.2 1.5.1. We write a program that reads several transactions for the same ISBN number. Write the sum of all transactions that were read. Okay, so first we ask for the ISBN number, right? Then I'll make a current book. Okay, right. So go first. We ask for the ISBN number, and okay, so we have units sold and revenue, right? Okay, so I want the book number and a variable price. So we'll go double price equals 0f. Okay, we'll keep a 0 because it defaults to 0. Okay, so I need the book number and the price. So this is it. This is a null string. This is a, well, it has indeterminate value, but we won't go into that. So right now okay, I'm good. So right now we are taking the book number. Now string current book. Okay, current book. Okay, we want to do this. So you ask for the ISBN number and set the current book number. So if we go cdcn data dot book number and then the price. Then we say that current book equals data dot book number. Right. Now we will check. Now to check if the ISBN number has changed. Are the solutions in the appendix? I wonder. Right. Pew. Okay. So this is page number. What is this? 51. 50. I remember that. Let's go to 0. Okay, there is 0. I'll go to 1. Okay. Right. Ooh, dynamic memory, shared pointers, smart pointers and exception, unique, dynamic array, new array. Nice. So there's copy, assign, destroy. Basket class. Okay. Bit set, big X, IO stream, large program, exception handling, namespaces, multiple virtual inherent, controlling memory allocations, placement new, private union, library. Okay. Library names and headers. A brief tour of the algorithms. Huh. There are no answers. There are no RAII. RA. Trailing return types. Nice. RAI. That's all. Template function and trailing return types. Okay, I think RAII is a paradigm. I think, as I suppose, that is a paradigm, right? Resource, yes. Resource acquisition is initialization is a programming paradigm particularly relevant in languages like C++ and Rust. It's a technique for managing resources by tying their life cycle to the lifetime of an object. Okay, this means resources are acquired when an object is created and released when the object is destroyed. Nice. Okay, so that's why we use unique pointers. Resource acquisition. If I type resource, come on, resource s on there's bound to be many. It doesn't even show it. I think it is hard for it to. Okay, if I write something, initialize acquisition okay, I'm wasting my time here. Let's get back to page number 51. Alright. Write a program that reads several transactions for the same ISBN number. Write the okay, then 1.5.2. Write a program that reads several transactions and counts how many transactions occur for each ISBN. Okay, for the same. So test the previous program by giving multiple transactions representing multiple ISBN. Okay. Records for each ISBN should be grouped together. I think I can do that. I think I will literally do this, which combines all of the programs. Okay, and header using compile and execute the I don't have that, sorry. Bookshare programs in total ISBN, right? So test the previous program by giving multiple transactions representing multiple ISBNs. Write a program that reads several transactions and counts how many transactions occur for each ISBN. Okay. Here, write a program that reads several transactions and count how many transactions occur for each. Okay, the test the previous by multiple transactions representing multiple ISBN. Okay, write a program that reads several transactions that counts how many transactions occur for each ISBN. So basically, what I'm doing is 1.2.3, right? This is basically 1.2.3, and I should open this 1.23. Okay, now check if the ISBN number is changed. If current book not equal to data dot book number, then we say that first we will show number. Okay, so I will just print the ISBN number, right? I will print ISBN, units sold, and total revenue. So I will go current book, the ISBN number, then the units sold, data dot units sold, and we'll say data dot revenue. So we have, and okay, then we set current book, right? We update the values, update the current book value. Then I want to data dot units sold equals 1. Update data dot units sold equals 1. If it is not same, update the number of units sold and revenue. Okay, hold up. So I can just go 0, revenue equals 0. Because I won't, because I right, what if, right, and data dot revenue equals price into data dot units sold. I hope it is units underscore sold. Okay, right. So we set this and this to 0. Okay, let me check. Right. Okay, so revenue, update the units sold and update the revenue. Now this is it. Then in the case if the ISBN number is same, then what we do is we simply update the units sold and then update the revenue. Okay, right. Yeah, so I've calculated that, and if it is same, revenue equals plus equals to, not plus equals to, it should be right, price. That's easy. We just add the price. Total revenue is data, right, plus. Okay, and then we, so I should okay, we go clear. You will 1.23 dot CPP dash main. Okay, revenue was not declared in the scope. Right, my bad. My bad. Data dot revenue and data dot revenue. That's all right. Data dot units underscore. It should be underscored. Yep. There we go. Okay. So let's say we have a book named Shane, and then we provide the price for it, right? So let's say price is 10. Right. Then we go Shane, and again price is 10. Then we go Ash, and price is 20. So Shane, item sold 2, and total revenue is 20. Right. Okay. Maybe I should add some space here. There we go. Let's try that again. And then in the end we do this again. Right. Okay, so we have Shane for 10, Shane for 10, Shane for 10. And we have Ash for 30, Ash. Oh, okay. So I have to take all of the data first and then I will print everything in the last, right? Okay, so I will take the data first and then I will print everything in the last. Shane 130 dash 130. Okay, if current book is not this, while CN data and price go revenue, I don't need to do this, right? We print the data about the last file at the end. Okay, so sales data string current books, we ask for the ISBN and we set the current, right? Then check if the current book is not equal to our book number. Then we take in the current book, unit sold, we are displaying, right? So we don't want to display it just yet, right? What can I do? Well, I can store all of that value in a string, right? Current book and string output. Let's store all of that in output. And then we store all of that in output and then finally print the output. So we go std out output std okay, so you cannot do that. All right. Equals this plus this plus this plus this. Okay, but wait. How did I do that, Okay, unsigned std, that's okay. You don't care about that. I think there was not here, but in the first chapter, I think in the exercises, adding two numbers, checking return status success 4.1 somewhere, yeah. There was some, and I don't remember how I did that. Okay. Anyways, minus 1 to 1. Okay, let's see. Okay, then I really should have it here somewhere because I know I did that, right? I'm pretty aware that I did that. Nope. Okay, basics, notes, initializing, output input while reading an unknown number of sum of values. Yes. Comments directive file redirection. Okay, that's okay. I think directives while in the while that I do know IO directives. What directives? Okay, so I really feel like I need to search, man. How did I do that? Introducing classes. That's okay. That's okay. The if statement, right? So we have the current value. So we have if std in current value, right? Then we count once. So the count of the current value we're processing, right? If the values are the same, add the count. Else, print the count of the previous values. Okay, I see in well if okay 42 occurred 5 times. Ooh, okay. So I loop is somewhat same, right? If these are equal, we increment the count. If these are not equal, while loop ends here. Remember to print the count for the last value in the file. See, I did somewhat same, right? Okay. Else yeah, bro, this doesn't work like that, right? I print everything else we do this, right? Press price. So okay, let me go Shane 10, Shane 10, then we have Ash 30, Ash 30, then I have that's okay. Say Shane 30, and then in the file and Ash 130. No, it should not be 1 because they are actually 2. Oh, okay. This should be 1 and this should be price. So there we go. Right, can I provide this from a file? Right. 26.2. No. Let's make a new text file. Let's say selections. Okay, so we go S10, 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 A20, A20. Then we have, let's say, R 50, and that is all. So let's try. So let's try it. The transactions or the transactions.txt. Let's try. I'm pretty sure that's how you do that. Nope. File redirection. That's how you do file redirection. Isn't that how you do file redirection? Operator reserved for future use. I don't know, man. That's how you do file redirection. Say file redirection. Oh, okay, because it doesn't work in PowerShell. My bad. We'll switch over to command prompt, CLS, and then we go main.exe transactions.txt. Right. Okay. Now that is wrong. That is wrong because I put it in a else clause. Right. And then let me just recompile it, and yeah, okay, great. It is 2, but let me just see the data over here. Are you 50? Okay, 3 units sold is 1. Oh, okay. 0. Yeah, right. Let me compile it again, and then let's try this. Yeah, there we go. There we go. Okay. That's what I want. So in actuality, I think I was actually right. That's the previous program by giving multiple transactions representing multiple ISBNs. The record for each should be grouped together. There we go. Grouped together. Okay, so this was actually 1.24. Don't print the output. We don't need the output. Show the price. So this and this. Okay. So there we have it. Okay, so this was actually 1.2.4. So I'll go here, switch back to PowerShell. Let's clear this. Okay, so I want to get rid of 1.23 dot cpp to 1.24 dot cpp, and then I want to remove the executable file. Okay, better. Yeah, I cannot simply compile that, so there we have it. Okay, no. Still? Oh man. Okay, writing our own header files finally. Okay, how much time do I have? Right, okay. Writing our own header files. Although, as we'll see, okay, we can define a class inside a function. Such classes have limited functionality. Damn. As a result, classes ordinarily are not defined inside functions. Okay. When we define a class outside of a function, there may be only one definition of the class in any given source file. Okay. In addition, if we use a class in several different files, the class definition must be same in each file. In order to ensure that class definition is the same in each, classes are usually defined in header files. Typically, classes are stored in headers whose name derives from the name of the class. For example, string library type is defined in the string header. Similarly, write sales data. Okay. Then headers usually contain entities such as class definitions and const expr variables. That can be defined only once in any given file. Okay. However, headers often need to use facilities from other headers. For example, because a sales data class has a string member, salesdata.h must include string header. As we've seen, programs that use sales data also need to include string header in order to use the book number member. As a result, programs that use sales data will include string header twice, once directly and once as a side effect of including. Because a header might be included more than once, we need to write our headers in such a way that it is safe even if the header is included multiple times. Okay, this is important. Whenever a header is updated, the source file that uses that header must be recompiled. Okay, a brief introduction to the preprocessor. The most common technique for making it safe to include a header multiple times relies on the preprocessor. The preprocessor, which C++ inherits from C, is a program that runs before the compiler and changes the source text of our programs. Okay. Our programs already rely on one preprocessor facility, #include. When the preprocessor sees a #include, it replaces the #include with the contents of the specified header. Okay. Nice. So that file, so that means that everything gets defined into one single file, right? C++ programs also use a preprocessor to define header guards. Header guards rely on the preprocessor variable. Preprocessor variables have one of two possible states, defined or not defined. The defined directive takes a name and defines that name as a preprocessor variable. There are there are two other directives that test whether a given preprocessor variable has been defined. Okay, if def is true if the variable has been defined, and if not def is true if the variable has not been defined. If the test is true, then everything following the if def or if not def is processed up to matching end def. Okay. We can use these facilities to guard against multiple inclusions as follows. Right. The first time sales data sales underscore data is .h is included, the if not defined test will succeed. Okay. The preprocessor will process the lines following if not defined up to the end if. As a result, the preprocessor variable sales data h will be defined and contents of sales data h will be copied into a program. If we include sales underscore data dot h later on some file, the if not defined directive will be false. The lines between the end of directive will be ignored. Okay, nice. The preprocessor variables do not respect C++ scoping rules. Okay. Preprocessor variable preprocessor variables including names of header guards must include preprocessor variables including names of header guards must be unique throughout the program. Typically, we ensure uniqueness by basing the guard's name on the name of the class in the header. To avoid name clashes with other entities in the program, preprocessor variables usually are written in all uppercase. Okay. Headers should have guards, even if they aren't yet included by another header. Header guards are trivial to write, and by habitually defining them, you don't need to decide whether they are needed. Okay, then we have a chapter summary. Types are fundamental to all programming in C++. Each type defines the storage, blah blah blah. Type const, address alias declaration using name equals. Did I auto type aliases? I define using? Nope, I don't want to keep it. You can go using type def decal type. I must have defined auto specify within decal type. Yes, decal type. Then I also join the auto type specifier. Yeah. Okay. Okay, so let's move on. Then we move on to chapter 3, vector strings and arrays. Namespace using declaration, library string type, library vector type, introducing iterators, arrays and multidimensional arrays. Okay. In addition to the built-in types covered in chapter 2, in addition to the okay, so in addition to the built-in types covered in chapter 2, C++ defines a rich library of abstract data types. Amongst the most important library are string, which supports variable length character strings, and vector, which defines variable size collections. Associated with string and vector are companion types known as iterators, which are used to access the characters in a string or the elements in a vector. Okay. The string and vector types defined by the library are abstractions. The string and vector types defined by the library are abstractions of the more primitive built-in array type. This chapter covers arrays and introduces the library, vector and string types. Okay. So let's see. The built-in types that we covered in chapter 2 are defined directly by the C++ language. These types represent facilities present in most computer hardware, such as numbers or characters. The standard library defines a number of additional types of a higher level nature that computer hardware usually does not implement directly. In this chapter, we will introduce two of the most important library types, string and vector. A string is a variable length sequence of characters. A vector holds a variable length sequence of objects of a given type. We'll also cover the built-in array type. Okay, like other built-in types, array represent facilities of the hardware. As a result, arrays are less convenient to use than the library string or this. Before beginning our exploration of the library types, we'll look at the mechanism for simplifying access to names defined in the library. Okay, what is the time for yo? Okay, so we go here, namespace using declaration. Maybe if I could add something. Okay. Up to now, our programs have explicitly indicated that each library name we use is in the std namespace. Right. For example, to read from the standard input, we write stdcin. These names use the scope operator, which says that the compiler should look in the scope of the left-hand operand for the name in the right-hand operand. Right. That's stdcin from. Referring to library names with this notation can be cumbersome. Fortunately, there are easier ways to use namespace members. The safest way is a using declaration. Using namespace and name. Okay. Okay. A using declaration let us use a name from a namespace without qualifying the name with a namespace underscore name prefix. Okay. A using declaration has the form namespace this. Okay. Once the using declaration has been made, we can access name directly. Okay. So std. Okay. So there we go. A separate using declaration is required for each name. Each using declaration introduces a single namespace member. This behavior let us be specific about which names we're using. As an example, we write using declaration for the library names it uses. Okay, so we have using this and this. Okay, cout. The using declaration for scene, cout and endl mean that we can use those names without the std prefix. Recall that C++ programs are freeform, so we can put each using declaration on its own line or combine several. Okay, yeah. The important part is that there must be a using declaration for each. The important part is that there and did I okay, then we move on to strings. Namespace using mine show. I think mine.show, and I can just write show here. Right, should be able to do that. Let's exit this, open it here. Let's make right. Okay, C++. Okay, error expected before this token. So for function names, this is my namespace. Okay. You must specify uh, the using declaration for each item wish to you wish to use from the namespace, right? Okay. Headers should not include using declarations. Okay. Code inside headers ordinarily should not use using declarations. This is that the contents of a header are copied into the including program's text. If a header has a using declaration, then okay, every program that includes that header gets the same using declaration. As a result, a program that didn't intend to use specified libraries might encounter unexpected name conflicts. Okay, this is all important. A note to the reader. From this point on, our examples will assume that using declarations have been made for the names we use for the standard library. Thus, we will refer C in and not in the text and in the code examples. Moreover, to keep the code example short, we won't show the using declarations, nor we will show the necessary hash include directives. Appendix list of name corresponding headers and library. Okay. Readers should be aware that they must add appropriate hash include and using declarations for compiling. Sorry. Okay. Rewrite the example from one. Maybe I'll do it next time. For now.